Hello my dear students, welcome to my channel Dey Sir's Chemistry Coaching. I think you have understand my topics and enjoyed it. Today I am going to deliver lecture on another new topics, that is nucleophilic addition reactions. You know that aldehydes and ketones are called carbonyl compounds, and carbonyl compounds easily undergo nucleophilic addition reactions. Do you know why? Because the carbonyl group, that is C double bonded O, is polar in nature. Positively charged carbon gets attached to nucleophile, and thus the reaction occurs. This type of reaction is called nucleophilic addition reactions. This is the main characteristics reactions of aldehydes and ketones. Okay, now let's start. Please remain till at the end. So today's topic is nucleophilic addition elimination reaction. Simply it is called nucleophilic addition reactions. Do you know what are nucleophilic addition reactions? Listen now. Aldehydes and ketones together are called carbonyl compounds. This is called carbonyl group. Both aldehyde and ketone contains carbonyl group. That's why aldehydes and ketones together are called carbonyl compounds. So remember it, due to the presence of carbonyl group in aldehydes and ketones, together they are called carbonyl compounds. You know that oxygen is more electronegative than carbon. The electronegativity value of oxygen is 3.5 and carbon is 2.4. Due to more electronegative, oxygen attracts one pi bond. You know that a double bond contains one sigma bond, one pi bond. A triple bond contains one sigma and two pi bonds. As pi bond is very weak and it can easily be delocalized, that's why due to more electronegativity of oxygen, oxygen attracts the bonding electron pi bond towards it. So there is a distribution of positive and negative charge. Carbon possesses positive charge and oxygen possesses negative charge. Hence, it is polar in nature. Polar. Due to the difference in electronegativity, if there is distribution of positive or negative charge, that is called polar nature. Due to the polar nature of carbonyl group, nucleophile easily gets attached to the carbonyl carbon, and thus nucleophilic addition reaction takes place. You get nucleophilic addition reaction and this type of product is formed. Now remember it, the extent of nucleophilic addition reaction depends on the development of positive charge on carbonyl carbon. greater the positive charge on carbonyl carbon, more will be the reactivity towards nucleophilic addition reaction. So write down, okay, write a short note. The extent So write down, okay, the extent of nucleophilic addition reaction depends on the development of positive charge on carbonyl carbon. Greater the extent of positive charge, more will be the reactivity. So write down. So greater the extent of positive charge on carbonyl carbon, more will be the reactivity. Now understand it. If electron withdrawing group is attached to the carbonyl carbon, then the development of positive charge becomes more and reactivity increases. So what you learn? Presence of electron withdrawing group such as benzene ring, such as cyano group, such as halogens increases the reactivity of carbonyl carbon. So listen, presence of electron withdrawing group such as benzene ring attracts the electron and the development of positive charge on carbonyl carbon becomes more, because oxygen also attracts electron, benzene also attracts electron. So due to the attraction of two different electron attracting groups, the positive charge develops more. So the reactivity towards nucleophilic addition reaction increases. Can you tell me it is aliphatic or aromatic aldehyde? Yes, correct. Very good. It is aromatic aldehyde because the functional group carbon directly attached to benzene. Here it is aldehyde, maybe ketone, maybe carboxylic acid, any functional group carbon. If attached directly to benzene, that is aromatic. In reverse sense, we can say that presence of electron donating group such as alkyl groups decreases the positive charge on carbonyl carbon and thus reactivity decreases. So write down presence of electron donating groups presence of electron donating group decreases the positive charge on carbonyl carbon, so reactivity decreases. This is aliphatic aldehydes because there is no benzene ring directly attached to the carbonyl carbon, so it is aliphatic aldehyde. So we can conclude aromatic aldehydes, due to the presence of electron withdrawing benzene, is more reactive than aliphatic aldehydes, isn't it? So this is the very important questions. I think this question may come in your Term-2 board exam. So write the question. So write the question, why aromatic aldehyde is more reactive than aliphatic aldehyde? If this question will come, it carries 1 mark, okay? But this is very important for this time. Whenever this type of question will come, at first draw the structure of the concerned compounds. This is benzaldehyde. It is an aromatic aldehyde. That is acetaldehyde. It is an aliphatic aldehyde. Now, we know that benzene ring has electron withdrawing nature. Any alkyl group has electron donating nature. So we can conclude that presence of electron withdrawing group presence of electron donating benzene ring increases the positive charge on carbonyl carbon. So reactivity of aldehydes towards nucleophilic addition reaction increases, while in acetaldehyde, due to the presence of electron donating methyl group, the development of positive charge on carbonyl carbon decreases. So reactivity decreases. So how to write the answer? Okay. Write it please. Okay. Continuation. Clear? So presence of electron withdrawing benzene ring increases the positive charge on carbonyl carbon, say benzaldehyde. So the reactivity towards nucleophilic addition reaction increases. So here one benzene ring, it will be more clear to you. Okay, this way. While if we consider aliphatic aldehyde, see there is electron donating alkyl group. Here it is methyl, it may be any alkyl group. So aromatic aldehyde is more reactive than aliphatic aldehyde. Okay. Now, how to compare the reactivity between aldehydes and ketones towards nucleophilic addition reactions? Listen, remember it, the topic which is going on is important for your term 2 exam as well as for entrance. Clear? So, which is more reactive? Aliphatic aldehydes and aliphatic ketone. Actually, why I mention aliphatic? Because there is no benzene ring in the compound. Okay. If this type of question will come, at first draw the structure of the given compound. Draw it, okay? Now tell me, which is more reactive, aldehyde or ketone? See, I have mentioned the electron donating nature of alkyl group by giving arrow. Aldehyde contains only one electron donating alkyl group, while ketone contains two electron donating alkyl groups. So, you know that presence of electron donating alkyl group decreases the reactivity. Obviously, presence of two electron donating alkyl group decreases the positive charge on carbonyl carbon more than this. So we can conclude that aldehydes are more reactive than ketone. I think it's clear. So let's write the answer, okay? I will write answer here. Clear? Now listen, the extent of nucleophilic addition reaction does not only depend on the electron donating or withdrawing nature of the group. They are called inductive effect, you know already. The extent of electron nucleophilic addition reaction also depends on steric hindrance, that is bulky group effect. Remember it, any reaction in chemistry, if does not occur due to the presence of bulky alkyl or aryl group, bulky means having more number of carbon atoms, then the nucleophile does not find any suitable path to attach to the carbonyl carbon. That's why reactivity decreases. This is known as steric hindrance or bulky group effect. Now try to understand, okay? So write down effect of steric hindrance or bulky group effect towards nucleophilic addition reaction. If bulky or larger alkyl or aryl, you know that when benzene is attached to anything else, that's called aryl or phenyl, okay? Then the if bulky or larger alkyl or aryl group, methyl, ethyl, propyl are called alkyl groups. But larger means maybe propyl, maybe isopropyl, maybe isobutyl, maybe tertiary butyl, maybe neopentyl groups. When they are attached to the carbonyl carbon, then the nucleophile, that is an attacking reagent, gets less space to attach to the carbonyl carbon, that is positively charged carbonyl carbon, and reactivity decreases. This is known as steric hindrance. This factor is called steric hindrance, okay? I think you clear it. Now see some very important previous years board as well as entrance question relating to steric hindrance, okay? Arrange these compounds in decreasing order of reactivity towards nucleophilic addition reactions. If such type of question will come, then at first search which are aldehydes, which are ketone. aliphatic in nature, and you know that aliphatic aldehyde is more reactive than aliphatic ketone. So listen, number 3 is an aliphatic aldehyde. Number 1 and 2 are ketone, and we know that aldehyde is always more reactive than ketone. So number 3 is the most reactive. Now, if you consider 1 and 2, see, compound 2 contains more bulky groups. Do you know what is the name of this compound? One is called diisopropyl ketone. These are isopropyl groups, okay? Later on, in another class, I will discuss different bulky alkyl groups such as isopropyl, isobutyl, secondary butyl, tertiary butyl, neopentyl, amyl, okay? In any another classes, okay? Now it's not required this thing. So listen, tertiary butyl group are more bulkier than isopropyl group. That's why we can say that compound 1, that is diisopropyl ketone, is more reactive than di-tertiary butyl ketone, that is compound 2. So according to the question, as it is mentioned that arrange in decreasing order of reactivity, so we can conclude that the highest reactive is number 3 and the least reactive is number 2. It is least reactive. So how to arrange the order? Decreasing order of reactivity, 3 greater than 1 greater than 2. When any question is related to decreasing or increasing order, if explanation is asked, then only explain about the highest and the least. continuation. Okay. So I think you clear it. Okay. Now write down another question relating to nucleophilic addition reactions. Okay. Remember it, sometimes instead of mentioning nucleophilic addition reaction, they directly give reactivity. If any question relating to reactivity of aldehydes and ketones, so remember it, that is actually nucleophilic addition reactions. Remember it, okay? Can you tell me what are the name of the compounds? You should know the name, okay? Actually these are aromatic compounds, and in aromatic compound, in most of the cases, commercial names are used, okay? So these are the very important compounds, especially 2 and 3. So remember their name. So write the name at first. Compound 1 is called benzaldehyde, compound 2 benzophenone, and compound 3 acetophenone. Now can you tell me which is the most reactive? Listen, compound 1 is an aromatic aldehyde. Compound 2 and 3, they are ketone. And you know that aldehydes and ketones, if you consider 1 and 3, especially if you compare 1 and 3, see, in 3 the keto carbon is attached with methyl group, and you know that methyl group has electron donating nature, so decreases the reactivity. So if we compare 1 and 3, benzaldehyde, that is compound 1, is more reactive than compound 3. can you tell me why compound 2, that is benzophenone, is the least reactive? See the structure of the compound. In one side of ketocarbon, middle carbon is ketocarbon, benzene ring is attached, and in another side that's also benzene ring, remember it, another side that is also benzene ring, okay. So in compound 2, due to the presence of two bulky benzene ring, steric hindrance takes place. So reactivity towards nucleophilic addition reaction decreases. That's why benzophenone is the least reactive. So you have to write the explanation for benzophenone, why it is least reactive. Just mention due to steric hindrance, okay. Continue answer. Answer continuation, okay. So I think you understand it, okay. Now write it. So benzophenone is the least reactive, that is compound 2, due to steric hindrance of two phenyl group. Actually, do you know what happens? What is the main thing, steric hindrance? No need to write in the answer, just understand the last topics, okay. But don't write, only understand it, this much. If this question will come, this is the very important question for board exam as well as entrance, right, up to this extent. Now listen, actually what is the steric hindrance? Say, imagine it. Here it is carbon, carbonyl carbon. Face is carbonyl carbon, okay. This is one benzene ring, this is another benzene ring. Actually what happens, this type of reaction takes place in solution, in liquid medium. Now benzene ring this way rotates, so rotates like wings of birds. That's why the nucleophile cannot come directly to the carbonyl carbon. This is known as steric hindrance. This is known as steric hindrance. Remember it, in organic chemistry there are large numbers of reactions which does not occur in presence of bulky alkyl or aryl group. These are called steric hindrance. So this much today. In my next videos, please see the examples of nucleophilic addition reactions. These are also very important for board and entrance. A humble request is that if you enjoy my classes, please do subscribe and please tell your classmates, friends and relatives to subscribe my channel so that I can reach to you. Thank you for being with me, okay? Thank you.